First, welcome. I'm John Goodhue. I'm the Executive Director of the Massachusetts Green High Performance Computing Center and also a member of the steering group for the Sharing and Cyber Infrastructure Working Group. We typically start these by going around the virtual room. Got about 18 people here. If you could just briefly introduce kind of who you are and where you're from, and I'll just call the steps from my array here, starting with Renata.
Hi everyone, I'm Renata Rawlings-Goss. I'm the Executive Director for the South Big Data Innovation Hub, and I'm at Georgia Tech.
Melissa?
There, I'm practicing using the space bar to unmute. Melissa Cragen, I work at SDSC, formerly the Midwest Big Data Hub. Great to see everybody on the call. Yeah.
And just as a heads up, you and Christine can later on fight over who does the OSN update. Florence, you get to introduce yourself with your new hat.
My new hat. I know one of my hats. So this is Florence Hudson, and I'm currently interim executive director for the Northeast Hub. But I've been participating in these for a while as I've been special advisor for the Northeast Hub in some areas. So it's great to keep working with you all.
And Shannon?
Hello, my name is Shannon McKean. I'm at the University of North Carolina, the Renaissance Computing Institute, and I'm the Deputy Director for the South Hub.
Jeremy?
Hello, yeah, I'm Jeremy Zollers. I'm also with the Renaissance Computing Institute, and I'm a project coordinator.
Marion, could you introduce yourself also?
Sure, I'm also with RENCI, a project coordinator, and we'll be here for the next month or so.
And everything that I say as a meeting moderator that sounds anywhere near intelligent is because Marion helped me figure out what to say. Just to give it credit where it's due. Rob, we'll introduce you later. Leah.
Hi, Leah Shanley, Senior Fellow at the University of Wisconsin-Madison and former co-chair of this a while ago, and delighted to be here. Thank you. Thanks, Christine, for mentioning it, and thanks to our congratulations to Florence, your new role.
Welcome back. Jay.
Hi, this is Jay. I'm a professor and director of global outreach for Global Cybersecurity Institute at RIT, Rochester Institute of Technology.
And Jason?
I'm Jason Kopowski with the Renaissance Computing Institute and the Executive Director of the IRODS Consortium.
And Alfonso?
Hi, I'm Alfonso Torres. I'm an assistant professor at Utah State University.
And Chuming?
Hi, this is Chuming Chen. I'm an associate professor of the Computer and Information Sciences, University of Delaware.
Tobin?
Hi, I'm Tobin Bagley from the University of Wisconsin-Madison. I was doing data management in the libraries, but now I'm in research cyber infrastructure in the Department of IT.
Christine?
Hi, Christine Kirkpatrick, proud co-chair of this working group and deputy director at the West Big Data Hub. Also at the San Diego Supercomputer Center, where I work on other fun projects that came out of this working group with John and Melissa, and fun to see all of you, and glad we can still be connected at this strange time, struggling to be a contributing member of society, and very glad it's Friday.
Patrick.
Hello, Patrick Clemens from the University of Vermont. I manage cyber infrastructure for the Vermont EPSCoR program there.
Tyler?
Hello, everyone. My name is Tyler Murray. I work for the Institute of Marine Remote Sensing, and I'm here representing the 3D Wetlands South Big Data Hub Spoke project.
And there's one person on the phone, area code 305. Is that somebody new or somebody who's just connecting by phone?
That's me. I was not able to Zoom in. My name is Ge Peng, and I'm a researcher at NC State University, and I'm always interested in the data quality and FAIR digital object framework. Rob had put in about this particular working group meeting a couple of days ago at a FAIR webinar. So I'm just kind of listening to see what's going on, and it sounds like a very exciting working group with various different stakeholders.
And a good place to exchange information. So thank you. Let's move on and talk a little bit about the hubs. So I think we have someone from every hub. Florence, maybe I'll start with you in the Northeast Hub.
Sure, that sounds great. Thank you. So one of the big things that we've been working on is that a week ago tonight, NSF reached out and said that they would like the hubs to work on developing an NSF rapid COVID commons. And this would be an information source highlighting the NSF rapid grants, which are fast, but rapid has, I think it's an acronym too, of course. And so there are currently 22 NSF rapid grants that have been announced regarding COVID. They're planning on more, including in the Convergence Accelerator. So we've been working with all the hubs, which we're very grateful that we're such a solid community, to put together a proposal to develop this NSF COVID Commons, starting with the rapid grants that are announced, and then looking at connections to the Open Knowledge Network, Convergence Accelerators, and maybe some other analytics and tools. So that's what's been keeping us super busy. All last weekend kept me busy. And then the beautiful thing is we have letters of collaboration from all 4 hubs, from OSN, and John, thank you for helping on that as well, and Christine as well, and everybody, and Renata and the whole family. So that's what we're up to. We're hoping to get that submitted today or Monday. We have, we're just waiting for a couple things, a couple of facility statements here and there, and sizing what we think is going to be needed for this. But it's very exciting and a great opportunity for us to work together in a unique and valuable way, which we've been looking for in this COVID area as soon as it started. So we're delighted to be working together. And that's what's taking up a lot of our time. I'm sure someone will talk about the All Hub Summit that was moved from May to October as a concept. Now we're trying to figure out the right venue, the right way to do that with, you know, I know I was supposed to go on vacation next month to South Carolina, and the people with the condo said, here's a letter from the governor saying that if you come here, you have to quarantine for 2 weeks, so you can't go outside the condo. I'm like, well, that doesn't seem like it makes a lot of sense. So, you know, I don't know when things like that are going to change. So for us to be flying somewhere, I might get to stay in the hotel if it happens. So we're working through what some of those things mean.
Got it. There were a couple of people from the South Hub. So I'll let you jump ball for that.
I'm happy to give an update on what we're doing. In the South Hub, what Florence was talking about is very salient. That's just this week. We've also walked a long road on for the last year now, working with the NSF on harnessing the data revolution. Their projects that are funded through that big idea, which and all of the PIs that are involved in those, trying to look forward to develop a meeting. So we're switching that meeting very rapidly. We did a survey as all of the hubs of the community, also a virtual meeting, and we were going to have a 3-day in-person meeting that was going to be partially a PI meeting and partially a forward future-looking meeting with recommendations around collaboration and coordination in the data science space. And so because of everything that's happening in the world, that is happening this month. And so we've switched it to a fully virtual meeting. We're going to be running it with the same collaboration feel, but with just the 3 days being fully online. So that's going to be an interesting update. And how the community may synergize. So this could play into some of the work that's going into COVID down the line as well.
Actually, we were working on rescheduling a meeting earlier this week. Seems to be going around it. And we realized, oh man, if everybody doesn't have to be in the same place on the same day, we don't actually have to have the meeting all on the same day. So we're going to work on spreading it out. So we're making a virtue out of necessity on some of this stuff. Let's see, Christine, or is there somebody who could talk about the West Hub?
Yeah, I could do that, and then maybe Melissa won't mind. I'll do this, and she could do OSN later, if that's okay. So the West Big Data Hub, Meredith's put together a very kind of just the favorite resources for people at the at westbigdatahub.org. Hope I got that right. So you can go there and you can see things like the oh shoot, I'm going to get all the nouns wrong, but it can get to the U.S. Digital Response. Let me pull this up real quick, which is a clearinghouse for if you need volunteers or U.S. Digital Response volunteer mapping. I'm just going to paste this one into the chat for people who haven't seen it. I think it's we've been thinking as a hub, what can we do in this time? And it's probably not to spin up new efforts, but to highlight and try and sift through everything that is bombarding our community and just the, everyone's an expert, everyone's doing something. And how do you find your place to the thing that you can help with? So that's just one resource, and there's a few others, again, carefully sifted through at westbigdatahub.org. We also have, so at SDSC, we host the Go Fair US office, which is all about implementing practices, be it training or infrastructure or different tools to make data more fair, which is findable, accessible, interoperable, reusable. And so this dovetails with some of the activities that we have planned for the West Big Data Hub in the second part of the grant that carry over from our activities in the first one, which were about research data management and best practices when it comes to infrastructure, and also, of course, with the specialization of at scale. So we've been very involved with Go Fair, host the U.S. Coordination Office, and starting this Wednesday with our first Zoom bombing experience for many of us, we launched our 4-part webinar, but we did actually, we only started 10 minutes late and we got into a new room and it all worked out. We had the introduction to the Virus Outbreak Data Network. This coming Wednesday at 9 a.m. Pacific, 12 Eastern, we have Dr. Mirjam van Rijssen, I hope I said that right, who will be presenting on how they're doing training capacity in Africa, especially as they try to gear up and confront COVID-19 with a much different and under-resourced, even more under-resourced than we're experiencing, of course, situation, and trying to make sure that the data is born fair so that it can be quickly aggregated and insights mined from it. So she will speak on Wednesday. And by the way, it's not just because we're interested in what's happening in Africa. Because they're mobilizing and doing this rapidly, they're actually creating a lot of training materials that we can use to build capacity here in the US. Then in week 3, we'll look at creating fair data points, which is this concept of, instead of data sharing, providing ways for people to get to data and make queries without actually ever taking control of the data, to try and ease some of the barriers to sharing. And then in week 4, we're going to have 3 different people, including Microsoft, Natalie Myers at Notre Dame, and then a couple people here at the Supercomputer Center, look at various ways that they're mining heterogeneous data. So not just from journals, but also geospatial, all kinds of omics data, and doing things like building knowledge graphs or even word clouds to look at trends in response. So we're pretty excited about it. I'm also part of the Virus Outbreak Disease Network, and I'm, along with Rob, part of the RDA COVID-19 working group, which is so immense. We have, I think, 300 experts signed up to help at the moment. It's spawned off 5 different working groups, from omics to social science to community outreach and some other things I can't think of at the moment. And so Rob and I, along with 1 or 2 other people, are RDA tab liaisons that will try and help the co-chairs navigate through the very aggressive timeline that the European Commission has given for some policy input they need. And then last but not least, I know I'm glad Florence mentioned the RAPID that she's working on. We also have gotten an inquiry from NSF to ask, are there federal data sets out there that would help researchers if they were open? And as we find them, if we could, please let them know so they can do what they can to try and help facilitate all of the data people need, that researchers need for modeling what is happening or doing the research that's needed. So I hope I didn't take too much time there.
Thanks. And is there anyone here from the Midwest Hub? I didn't see anyone on the roster.
Oh no.
Yeah, I'm part of the Midwest Hub, but I haven't been in touch with them on cyber infrastructure. I've been more collaborating, building collaborations with them more on digital agriculture.
Okay, yeah, I wasn't gonna burden you with that. Good. Why don't we go on? There's a agenda section for updates on outreach and engagement. We just heard a ton of updates on outreach and engagement. I wanted to
That
see
one I'll take gigs of.
if anyone had anything to add.
One thing we've started doing, this is Florence, is that as we're reaching out to members of the community, we're finding interesting virtual events regarding COVID at this point. So there's one I just put in the minutes. You can click through our homepage to our COVID site, but on there's an event as an example called Being Led by Body. I'm Italian, so I like to say it like that, but it's BARI. And they're having what are the other effects from COVID webinar on April 24th. And now that this stuff is virtual, anyone can participate. So I asked them, is it okay if anyone participates? They said, yeah. So I think this is an opportunity for us as all the hubs working together to kind of highlight these opportunities with each other without like bombarding each other. There's so many of them. But I know we're putting them on our COVID site, the ones that are COVID related. So I'm wondering what people think, about that.
Hey, Florence, I actually think that's a great idea. If there's a joint Google Doc where we can just kind of list these things, at least we can push them out to our various communities because there's quite a few. Even
What's the best way to do that? So we have them on our website, so you guys can just scrape them off our website if you want.
You can just make a link to the page is another.
Yeah, you can just make a link to the page as compared to keeping another Google Doc too, because I know I'm not going to be good at doing both of them. Is that okay, Renata, or is that not a good answer?
That's fine. It just doesn't allow us to send you ours without you just getting them as emails. So it works for me, but I don't know.
No, I understand. Okay, so I think we had a shared Google Doc that we got a lot of this from. Do you want to open it to more people? I think you and I and Meredith and John and Renee were on it.
I think that's fine. I mean, because then I think we'll probably be the biggest fire hoses of things, so that we could just keep that going.
Okay, and we're good consolidators too across the hub. So I'll make sure you have access to that and I'll send you the link. So I'm sorry if you weren't already on it, but I'll go find it in my 3000 Google Drive things. Okay, great, thank you.
Any other things to add? Let's see, Melissa, can you say a couple of words about the OSN?
There we go. Sorry, still having. It's okay. I'm getting the hang of this space bar thing. Yeah, so the OSN, we're having great success with moving toward automated or centralized and some automated management of the hardware and and managing the software when we have updates to the software, pushing those things out. Really great headway in working on our trusted CI assessment for cybersecurity. And we've got a number of new use cases that we're onboarding as well. The next big push, in addition, so the leadership team met this week. We have a handful of sort of top priorities to, we're going to be moving into a no-cost extension period, but a handful of top priorities for us to execute on over the coming months. And one of those efforts, and I think it'd be great if maybe in the early fall, I can come back and do a presentation to this group on our use cases, because one of the efforts, or late summer, one of the efforts that we're doing and is really necessary is getting some more information out about the use and users of the OSN, and actually being able to articulate sort of them as case studies so people can start to say, hey, we know of a project that really could use the OSN for X purpose. Again, a handful of new use cases. We've got a whole bunch now with allocations anywhere from 10 to 100 terabytes and larger. We actually have a group now working on spinning up a petabyte worth of data. That's going to take some time because we have to, they're going to get funding to recruit a whole new pod, to pay for a whole new pod for that. So it is exciting times, and we're looking for, we're open and ready for business. We're looking for new users. And in fact, Tyler, it's great you're on the call. If we, maybe it's time to circle back and talk about moving forward if you all are ready with some of the LiDAR data. So I'll leave it there.
So Melissa, we were talking this morning, one of the neat things you brought up then was like any project, you have a set of expectations about how people are going to use what you've got. And we're now in that period where people are coming to us and saying, we want to do this. And it's like, whoa, we never thought of that. So the user community is inventing new uses as we go, which is kind of fun. And that's a teaser for your talk later this year.
Thank you.
Let's move on. Is there anything else, anything that anyone else wanted to bring up before we move on to the main event?
This is Payne. Can I make one point?
Certainly.
Okay, I'm affiliated with the NOAA data centers. So we've been actually looking for how users can use our data if they need to, especially meteorological data, climate data, that they find they're hard to get or hard to use, and we'd like to hear about it. So along the NSF call, I'm wondering if you guys are in the situation like that and would like to contact me, so I will be able, more than happy to forward the request to the data center management.
So Ping, this is Melissa. Are you asking specifically about the open storage network?
No, I'm affiliated with the NOAA data center. I do some research on the data stewardship and data fair, etc. like that. But currently, the data center management actually are looking for feedback in terms, if and how the user, especially with the COVID-19 challenge, if they can use our data, if they needed to, or do they have a difficulty finding it, or if they don't understand or how to use it, how to integrate it into their system. So if a situation that any one people in the hub in the situation that needs to get the data could not, or the data are not very good to be integrated, and that will be a great feedback for us to improve our data.
Okay, that sounds great. Why don't I follow up with you if that's okay? I'm going to send you my email address through the chat privately, and why don't I follow up with you, and then see if I can't hook you up with somebody in the hub that might be a good contact. How's that?
Okay, I'm not in the Zoom, so my email address is gpayne, G like George, P Peter, E Edward, N Nancy. Why don't I put it in the notes?
That's fine.
Could, oh, okay.
That's
and your
fine.
name is?
It's Melissa.
And your name is?
Melissa. Melissa.
Melissa. Thank you. Okay.
Okay. Ciao. Yep.
Sounds good. Anything else? Hearing none, I'll do a quick introduction. So Rob Quick is the Associate Director of the Cyber Infrastructure Integration Research Center. And at Indiana University, he can talk a little bit more about who he is and what he does. And he is going to talk to us about persistent identifiers. And again, you've seen the abstract, so I'm going to just turn it over to Rob and let him do a better job of introducing.
Okay. Can everybody see my slide here?
Yes.
Okay, very good. And you can hear me okay?
Yes.
Okay, very good. So thank you for the introduction. I will talk a little bit more about my position and what I'm doing, but I wanted to start with this short story and picture, and this is a real picture of me and my daughter as I was preparing slides for this presentation yesterday. She asked me what I was doing. I said, I'm working on important slides to tell people about my work. And she said to me quite seriously, just tell them science and come play. So I wanted to just say science and cut my presentation short. But really, this is, I think, the reality for a lot of people now is that they're working from home and have various different interruptions. So please do excuse me if you hear some laughter in the background or such, because I am working from home, as many of us are, and have interruptions occasionally. If there's an interruption, I'll just say science and stop and go play. But how do I forward this? Next slide. There we go. But I'm going to talk a lot about persistent identifiers. One form of persistent identifiers that everybody's familiar with are DOIs at this point. PIDs is just kind of a general description of a DOI being one form of PID with its own specific standards and metadata behind it. PIDs that I use are going to be very generalized, just as persistent identifiers. And I often say rapid, and I know that several people earlier were talking about various rapid NSF proposals. When I say rapid during this, I'm referring to robust persistent identifiers. So please excuse the clash in acronyms there. So when I first started with RDA, and it was back at, it was in Amsterdam, and I think it was P4, the fourth plenary. It may have been a bit earlier than that. But somebody said in one of the presentations, data everywhere, nor any drop to drink. And everybody recognizes that from the Samuel Coolidge rhyme of the Ancient Mariner, with the insertion of data versus water. Now, the question we've been asking ourselves in the RAPID project is, and RAPID again being persistent identification of data, is not only how can we make some of that water drinkable that we're surrounded by in oceans, but how can we make all of that water drinkable? And that's really what I'm going to talk about now, is a very an overview of what we could do to make data universally interoperable, and one scheme to do that. So let me say, first of all, that many of the contributions in these slides, and there are only 15 of them, so you can see what a collaboration this is. I think there's 15 of them, and it looks about half that many names that contributed to this presentation. But they all have contributed in both intellectual and actual slides during this presentation. So they deserve as much of the credit for this work as I do. Myself, I am at Indiana University. I am the Associate Director of the Cyber Infrastructure Integration Research Center. This was previously known as the Science Gateways Research Center. We've really kind of changed our view to look at all of cyber infrastructure and integrating the cyber infrastructure that's available to researchers into a usable format, something that, and people have heard it many times now, the scientists can do their research and not worry about the technology, not become IT experts along the way. I'm also the principal investigator for the NSF project called the Enhanced Robust Persistent Identification of Data. It was previously in a prior grant called the Robust Persistent Identification of Data. That was started by Beth Plaley, and I took over for her when she moved to NSF, and she deserves a lot of the thanks for the initial ideas here and what is in this presentation, along with really pointing me in this direction to think about what does this universal interoperability mean. I'm also with EXCEED, and I run the Extended Collaborative Support Services Science Gateways portion. So I have a connection to the cyber infrastructure there. And on the RDA, I'm part of the Technical Advisory Board along with Christina. And I'm the co-chair of the RDA Data Fabric Interest Group, which really a lot of these ideas were fleshed out in here. In fact, the data interest groups came and they had all these puzzle pieces that we said, well, can we make this a real fabric that is then useful for the community? So I'm gonna start really big here and make a suggestion that there are three main eras of IT, and that we are in the middle of the second era and moving towards a third. So that first era was basically from the invention of computing and transistors to about 1995. And in this era, there were really many computers and many data sets. Occasionally, a single computer was connected to a single data set, usually via a mounted drive. But for the most part, all computers operated heterogeneously and all data sets the same way. Of course, with the 1995 and the proliferation of the internet, we went into this new era where there were now a single computer and many data sets. The single computer being that all computers could talk to each other in a single, with a single communication protocol. And you may recall Sun had a marketing slogan called, that said, "The network is my computer." So in this era from 1995 till sometime hopefully in the near future, we're in an era where data sets are still heterogeneous, but really there's a homogeneous computing structure. Now, you can probably guess from era 1 and era 2 what the third era may be. And again, 2025 is just a projection. I think that it may be, there will be schemes for it sooner. Whether it'll be widely accepted, it might be after that. Is of one single computer and one single data set. And by that, I mean there will be interoperability of all heterogeneous data, meaning that you can interact with all heterogeneous the same way. And this is actually from a small white paper by George Strawn. For those of you who don't know George, make it a point to meet George. He's with the National Academy of Sciences and just a wonderful person to talk to. He was part of NSFNet and really the formation of that initial networking technology that came to be the internet over time. But I hope that everybody here gets a chance to meet George because he's just a wonderful person to talk to. And we have kind of a motivation for making all that data into a single heterogeneous data set. And that motivation is really the Internet of Things and machine learning. Internet of Things have made, and sensor are inexpensive. So you now have all this data. Machine learning will require a better data infrastructure if we're really going to see how far it can go, where we can push these new machine learning techniques. And even when data remains in silos, global fair data infrastructures could automate that data wrangling step, which anyone who has spent time really trying to work the pre-processing up to a analysis knows is a majority of a data scientist's time. Whether this 80% is realistic or not, I'm not sure, but that's the estimate in some areas. And we really see this emergence of open science. And this emergence of open science, at least some advocates are saying, will have the same impact, and it will rival the original science revolution. Making science open and available to all can really have a massive impact as everyone starts using the data available and in fact the resources and instruments available also. It's easy to see that if we have that those three eras and the data infrastructure coalesces as the internet and the web did, that data infrastructure will be revolutionary. And interestingly enough, the two capitalized words here, internet and web, coalesced around two specific things, and those were protocols. The internet around TCP/IP, which basically meant all devices could talk to all other devices without having any specialized software. All you have to understand is TCP/IP, and the web was HTTP, the protocol that allowed every web browser to understand bits in a certain sequence and to make them into something readable by a human. So, so data sharing and interoperability has kind of a long history, and this history really, and why we're moving towards fair and open data is combined in several things. One is the technology advances. We've gone in the 1970s from thousands of transistors on a chip to now 1 billion transistors on a chip. The networking technology and fiber optic and laser communications have gone from, I wrote down the first thing megabits, but I remember having a 300 baud modem, which means it was hectabits per second, to now experimental petabytes per second networks. Disk prices have dropped tremendously. It was $500,000 for a gigabyte of data in 1981, and now that's about 3 cents per gigabyte, as you can get a 4 terabyte drive for about $100. And these great performance increases, along with, have enabled this data intensive science and things like machine learning, and the complex algorithms are now realistic as they weren't before. At the same time, society and government has been moving forward. In 2011, there was a U.S. federal interagency committee that said, basically at this time, we can now store more data than we can effectively process. In 2013, we had a U.S. presidential science advisor signed an executive order, and that required that all federally funded research be openly available, so leading to, again, open science. Then January 2014, there was a workshop in Leiden University that was led by Professor Baron Mons, who was actually part of the VODAN meeting earlier this week. And the result of that meeting was really the definition of fair data. So I think everybody in this room probably understands what fair data is, but just to rehash that, and I actually have some details on the next slide, but that's findable, accessible, interoperable, and reusable. And then this one is a little less well known, but there was a National Academy of Science paper last year, I'm sorry, it was in 2018, so I guess 2 years ago now, that included a recommendation that all research products be made available according to FAIR principles. So we're really pushing along the lines of this open science and these FAIR principles as a way to allow open science to happen. And how do you reach interoperability? Interoperability has for a long time been a tool used for by computer scientists to create new levels of abstraction. So you have high-level languages that and interpreters that solve the interoperability problem for heterogeneous computers. You have the internet that solves the interoperability problem for heterogeneous networks. And the question is, can this digital object architecture, which is at the base of these persistent identifier schemes, can that solve the interoperability problem for heterogeneous data? Just to reiterate the FAIR principles, and what I've done on this slide, and in fact, this slide, I did this with Luis Benino from Leiden. This slide separates what's in green in the FAIR principles, and these are the FAIR principles word by word. What's in green is what can be accomplished purely in a technical level, and then in black, what needs the community to provide some solutions, along with, though the technology can still aid in those things. You'll see things here like the first one, metadata is assigned a globally unique identifier. We can do that with technology. That technology has existed for a long time. The persistence part is not a technical solution. The persistent parts requires the community to say that they will house these registries of persistent identifiers for long periods of time. The same thing with point 2 here. We can make a technical solution to have a way to describe metadata for the data. Whether it can be rich is really going to fall on the community. And you can go through the rest of this, but really what we focused on in the ERPID project and what we're really focusing on in the FAIR Digital Object framework is what's in green here. And there will have to be some society movement around the things that are in black or blue, whatever color that text is, the non-green text. So the DO.
May I ask a question, or is that inappropriate?
Sure.
Okay, great. If you could go back to your green and blue days. So one of the areas that is still research, but it's on this findable side, is name data networking. Have you been involved with that at all? And what are your feelings on that from this findable perspective? Do you think that will help?
So I'm aware of name data networking, and I did a compare and contrast for the ERPID proposal without digging into it too far. The one thing that is the major difference is the name data networking actually changes the base level networking protocols, right? So you need a change in networking. What the digital object architecture does, it operates within the initial or the existing networking framework. Now, I would say that the goal is the same for many projects, right? That can all water be drinkable? And it's more than likely going to be a combination of good ideas from many. I can't say enough to say whether, I don't know enough about name data networking to know if it's going to, what part it plays in, or if it solves some of these issues. However, I think that some convergence of several of these technologies is going to be the right answer, and we know what the solution is. The solution is that all water is drinkable. How we get there, I think the devil is in the details, right?
Okay. Thank you. I appreciate
think the thing that it has, so it's what I know of name data networking is it's very powerful. The downside of it is that it takes changes at the networking layer, and whether that is palatable by the community remains to be seen.
Yeah, so just a little more I want to share on that. So I used to work with Christos Papadopoulos on this a little bit when I was at Internet 2, and now he's at DHS, I think. So he was in Colorado. So the interesting thing when we did a meeting at NIST about it was that they had some posters with tanks on them. And of course, when you say, what's the use case? They say, oh, tactical, they can't tell you anything. But I think what they're looking to do is see if it actually provides a more secure, more valuable data networking and finding opportunity in an environment that they can manage, because it's the government, you know, it's the military. So there may be some interesting things coming out of that. So I just wanted to share that. We'll see what comes out in the public, but it might provide some interesting new opportunities. For those who don't know NDN, I think the idea is that you put the identifier on the front of the data packet. So you look for the data packet, you know, not the IP addresses, and as you know, is being shared, you have to change how you're doing networking. But it's interesting. So it may be a future innovation that could be valuable.
Yeah, and as I said, I think a hybrid solution is going to be the ultimate solution.
That makes sense.
There's going to need to be, you know, the network's going to need to be involved. It's going to need to be aware of what's happening with the data. If that takes, so again, I won't go too in depth because what I know about named data networking is not enough to say too much. But I do think that the network is going to have to be aware of what's happening with the, with data and be part of the solution.
Very well said. Thank you very
Bob,
much.
I have a comment. So you mentioned a number of times that all waters are drinkable. I'm wondering whether, because there's always a balance between resources and the result, I'm wondering whether make it all water available, but some water are drinkable, some water maybe we don't need to be drinkable, we just need to use to flush toilet or things like that.
Sure. And making all water drinkable, another important thing here, doesn't mean that anyone can drink any water, right? You have, I think it's here in point A12, is that there needs to be authentication and authorization also, meaning basically that you still have to live behind that authentication and authorization scheme, because you know there's a difference between open data and data that anyone can use anytime without some authorization and authentication. Did that answer your question?
In a way, I guess I'm wondering whether philosophically it's too much of a goal to requiring all data to be interoperable at the same level. Does that make sense to you?
So yes, but I look at this with the same idea of what happened with the internet, right? So the power of the internet and the networking protocol and TCP/IP is that all devices connect the same way, right? So the network doesn't need to know whether you're on a cell phone or a laptop or a internet-enabled refrigerator. The network is the same. So if we can put the technical components to be the same, that doesn't necessarily mean that you can interact with all data. And at the same time, you really have, you do have to say, people are going to come along in stages of this. Now, whether, yes, so there's a lot to be done both on the technical side and the community side to get to this stage. And some groups will come along faster than others. You can see again, when we went to that one computer model, that it became too, and as the internet developed, it became too expensive to not be a part of it, right?
Yeah, I think I understand what you're saying. Thank you.
Okay, so I've gone on here already 25 minutes, I see. So I do only have about, I'm about halfway through my slides, so I'll try to go through this quickly. The good thing is that the people who are really thinking about this and the brains behind this are the people who are involved with the internet. I mentioned George Strawn, but Robert Kahn, who is the executive director of CNRI, which created the handle system. The handle systems are what DOI uses as a technical background. This has been around for a while. Robert Kahn is also credited as the co-creator of TCP/IP. PIDs are persistent identifiers, point to digital objects, and provide a kernel of metadata, so some state data about that. This can be done at a very quick level. You can get information in that kernel of metadata, and that kernel of metadata is just enough metadata to do some base operations, much like you have a very base operations. HTTP only enables things like get, head, and post, and delete. There's a kernel of metadata that would allow you to interact and learn more about each of the digital objects. And a digital object can be anything. We have what is the Digital Object Interface Protocol. This plays the same role as HTTP for web pages. It facilitates those operations. And DOs can be anything that you can represent digitally. As people know, there are PIDs for all publications. DataCite does data now. ORCID does, puts PIDs on people, basically. So anything that has a digital representation can be a PID. Now, the PIDs involved in our testbed don't have to come from the testbed itself. They can be DOIs or PIDs issued by other agencies, as long as they're persistent and globally unique and resolvable. So I think that covered that one. One thing to say, digital object architecture here serves as base infrastructure only. So basically the technical components, it doesn't say anything about the modeling of data, the objects themselves. For that, we look to groups like the FAIR principles and the RDA working group on the PID kernel information. These relationships are defined outside of the technical realm. You can say that location represents the location of the digital object, for instance, and that's resolvable for the PID. But to say what else and what other objects what other metadata is available, that's left up to things like the FAIR principles and the PID kernel information. So really, this is just overlays from a user terminal or a user client to some bit stream, right? So the digital object infrastructure, digital object architecture allows end users to work with persistently identified digital objects, which basically they can get some information about from the various repositories from identifier services, which in the end just map onto some bit stream, whether that's streamed or written to a disk, or and again, regardless of what technology is used to write that, if it's on a SQL database or a file system or a DSpace repository structure. Again, interacting with it should always be the same. Now, the eRapid testbed, which is entering its second year of production, has the basic components, and really what we had was puzzle pieces from various different organizations that we stitched together. It really works with a PIDs, a handle service. A handle service, as I said earlier, is the same handle service based software that issues DOIs or well, DOIs is the big one, but there are a few other ones that are used outside of academia. It's the same software. The handle server is exactly the same. We had a Datatype registry. Data typing is important because if you're having this machine communication, you have to know the form of the data if you're going to act on it. For example, if you have a created on date in the state data of the PID, you need to know that that's coming in the some standard form that the machine can then parse and act on. The Datatype registry is where you register the types of the state data that you're going to get from resolving the PID. This helps you make decisions then as to whether that is useful. So the components really of RAPID are a handle service for issuing and resolving persistent identifiers, a Datatype Registry for recording what data types those are for machine actionability. We're working on a mapping service that really prevents the refactoring of repositories, right? So we understand that we're dead in the water if we go in and say, okay, you've got to change your repository schema to do this, that, and the other thing before it can be part of this structure. We really have to have something that maps what is in the existing repository to the digital object architecture. And we're working on that with DSpace is the one we're working on right now. And then that operations protocol, which is really the hinge of it all. And it's what I call the digital object interface protocol. And this allows the basic, so both basic and extended operations. The basic operations are much like HTTP. And probably the one that's most used will be a GET, because you find out some metadata about an object. You want to bring that object to your computing source or your screen so you can review it, whatever it may be. But there are the basic CRUD operations, which we've enabled in ERPID CRUD, the create, update, delete, and I always read. I always forget R. So basically this are two services that would be globally networked. There would be many of these, not just the ERPID service, which is its testbed, which is 2 servers sitting in Indiana. It would be a network series, our federated series of these handle and data type services, along with a protocol that functions with them. Let me talk about, so we have a wide variety of use cases. They include, oh, I went the wrong way. They include some weather modeling, some climate surveys in the Taiwan area, some Weiss genomics projects, actually JetStream as part of it with its virtual machine images. We had Galaxy as part of the project where we were looking at their workflows, but the one I want to center on and just mention here is the Science and Engineering Applications Gateway, or CGRID. If you go to rpid.cgrid.org, you'll find our testbed enabled in a science gateway. What it does basically is assigns PIDs for every aspect of the workflow. So each input, the raw data is assigned a PID. It's at this point assigned when it is when the workflow is started. However, you could imagine that a PID be assigned to raw data as it comes out of the instrumentation. There's some data preparation software or some pre-processing software that is also assigned to PID. The intermediate data products, again, PIDs, and down the line until you have your output and visualization, which are also assigned PIDs. This, in the end, could all be wrapped in a DOI, which then could be published outside. You wouldn't want to use DOIs on every step of the way because there are some requirements there that get pretty heavy. And this, you can imagine following a series of PIDs and that allowing you to totally reproduce a experiment. And in fact, even the resource that it runs on be given a PID, so you could potentially go back to the same resource. There's a little bit of questions about whether the architecture remains the same for any length of time that would allow that to be reasonable. But this is enabled in a gateway. This is all behind the scenes for the first run. So the researcher coming in for the first time doesn't even realize this is happening. When this becomes important is when they publish, they have a path to reproducibility to show basically the entire computational workflow end to end as to how they got their results. And I know I'm running long on time. I did want to also talk about the Fair Digital Object Framework. This is what several people in the U.S. and Europe are working towards. There's a Fair Digital Object Working Group. I have the link on my final slide here. But this combines the digital object architecture, which is over here on the left, even closer with the fair interoperability. It pulls in some linked data concepts for semantic relationships between the metadata, and then you have the a digital object that is fair. I would suggest talking or looking back over Baron's presentation for more on fair digital objects. But the idea is basically everything that I just talked about is given some semantic relationship to pull it from the digital object architecture and combine it with fair. And it also has a specific format, an RDF format that again is relatively available and usable. The general idea here is you have fair digital objects wrapped in PIDs that an agent can act upon when they decide that digital object is fit for the purpose that they're looking. And they can get that from the metadata that is part of the state data that you can get from resolving the persistent identifier. So going back and realizing that I'm going 20 minutes long here, the next year of IT, we talked about these. I will just say that I think this final IT era is coming, whether the technology we're working on or a hybrid technology, as I mentioned, that includes networking or some commercial group is going to develop something before we get this out the door. It waits to be seen, but I think we are moving towards that third era where we have basically a single data set that the technologist who is writing the client can interact with all data through with one method or with one protocol, basically. So realizing I hurried through the last half of my presentation, I will, if I have time, take questions.
I think just being respectful of people's time, what I'm going to do is just a quick note on upcoming presentations, and then people can hang around the virtual podium afterwards, but are also free to leave. So I'll just make a note that we'll be meeting again on the 1st of May. Stanton Martin is going to be talking about the National Biome Data Collaborative. Stanton's at Oak Ridge. And then you heard earlier, Christine Kirkpatrick, who's I think still on the call, will be talking about the virus outbreak data network on the 5th of June, and linking back to some of these FAIR principles. So with that, I think people are free to drop off the call, or Rob, it sounds like you've got a little bit more time, and anyone who wants to ask questions, have at it.
Yep, I can stick around for about 10 minutes, and I have a one-on-one with my boss, but he'll wait.
Okay. Any questions for Rob?
I just wanted to say, Rob, I really appreciated your presentation. I especially appreciated the last couple slides, which really wrap up some not only complicated concepts, but to be experiencing this as it develops in real time. There's so much to sift through about, you know, what is worth following and what's going to emerge as the way to do it. It's really nice to have a recent retrospective kind of what has emerged as things that we should be building around. So I appreciated that a lot.
Thank you. And I said a few things in there. I think I said the devil is in the details, and those details are working out. And the other thing that the Fair Digital Object Framework is that consortium is really looking at, and this is something that George Strawn tells us also, is that general consensus, which we think we have the general consensus of as to where we're going. And the second part of that is running code, which is really the part we're in now, is we're really trying to implement this technology in a way that is generally usable by anyone, right?
I also really loved the drawing at the beginning, and I think that one, it was just a timely way to frame the discussion, but I also think the more that we can support each other in our varying working styles and acknowledge that it's a different time, and that yes, your kids might be in the room, or you might be sharing a home office with a spouse, and things are different. I think that's just really good to interject and be real about with each other.
Yep, thank you. And again, I think you're right. Being real is important right now, and even approaching it with a bit of a sense of humor, I think is good.
Science, let's play.
We get more real as we get more virtual, right?
Yeah.
Here's a thing that wove in and out of your talk, and I also love the diagrams, especially in the last couple. It's a nice way to kind of present it conceptually. But kind of forever, there's a worldview that says we got to organize the data better and better, and then there's a different worldview, especially with the rise of machine learning, that says, let's put it in a pile and we'll figure it out. It looks like you've navigated that pretty well by providing layers that kind of in between that can support both points of view. But I wonder if you could comment on that tension, and in particular where you think the boundaries are on being able to, how far do we need to go to structure the data in the world to make it be usable, and how much should we just leave to people to figure out?
Yeah, so I would point you towards more of the details of the PID kernel information. In my opinion, you want to get the minimum set available for all data that allows you to do those base operations, which the base operations are your computer science first year. You want to be able to retrieve an object. You want to be able to put some basic trust, determine if it's the object you're looking for. So you need something like an MD5 checksum. You need a created on date. So that has to be very small, and it has to be very small for a very technical reason, is that this has to operate at internet scales, right? So you're looking at billions of these objects. So if you try to put all of your metadata into the associated with a PID, then all your time is going to be churning and trying to get through, tons of metadata. So we need, there are really two sets of operations. One, what's the base set of operations that you need to establish enough trust to know that you want to know more? And then when you want to know more, you need to probably still talk to a metadata server. And in fact, if you want to do complex operations, something like a visualization operation that takes in a certain amount of data and puts it into a visualization, or even as something as getting the average value of this field and all of these similar data objects, that you're going to have to then get some a more in-depth profile and that metadata still probably lives on a metadata server, not within the greater environment that allows you to quickly operate on billions of objects. Now you need a pointer in that PID kernel as to where you can find more, right? So when you're searching for an object, you want to know if that object is suitable or fit for use. So it comes to what is searchable, what is reasonably searchable, and then what is it that it takes to build the necessary level of trust that you're going to do some extended operation or some analysis with an object. So from a purely technical point, you want to keep that kernel as small as possible simply for a performance issue. But you also have to have that greater detail, and that greater detail is going to tell you, whether the units on the number you just picked up, so you know what you're actually calculating. And all of that needs to be recorded also, but you don't necessarily need that about every object. What you need about every object is where it's located, where you can get more data from it, and some very base metadata that allows you to establish trust that the object you're getting is the object you think it is, and authorization. So whether you can actually access that digital object or not.
That helps. Right? That was part of the genius of the internet, is what is the minimal set of operations that you need to make it all work. And,
right.
and I love it that the internet didn't exist before 1995. I'll take that under advisement.
So the internet, I will say, it absolutely did exist before that, though the genius of it really became widely used at that point, right? Which is as I said, the network doesn't care if you're using your cell phone, your laptop, your server in your data center, your kids' toys that have an IP address. It talks to them all the same way. The network itself treats them the same way. And that's what we really need clients to be able to treat data all the same way. And make some decisions based on some decisions based on what's available in the kernel, and then even more decisions based on what's in an extended profile or extended state data.
Well, I find it remarkable that there was a group of people who in 1968 kind of laid out the foundation that worked when things exploded in 1995, other than address space.
Yeah. And for, as long as computing, you would have one manufacturer could talk to the same manufacturer, right? So you had protocols that allowed Sun systems to talk to Sun systems say that anyway, you had protocols that allowed communication between like devices for as long as you've had computing. Well, not quite as long, but nearly as long as you've had computing. It's that genius of the network doesn't care, right? It can talk to you no matter what operating system or what hardware you're operating on.
Yeah.
Can I ask a question about what's your justification for really wanting resolvable identifiers as opposed to just global identifiers for such fine-grained objects? You've got data sets that have 100,000 files, and you've now got a resolvable ID for some intermediate data product that you'd really be hard-pressed to understand without understanding the whole data set. So why do we want to have a resolver service to be able to get to every single one of those individual things without having to find the main data set?
So
if that makes sense.
Let me say that you can do that. That doesn't necessarily mean that it's useful to do that and that you have to do that, right? At this point, we're still showing that you can. PIDs themselves are very inexpensive. The resolution is very quick as long as the kernel, the metadata doesn't get big. It's going to be useful in some cases and not useful in others. What we found in the CGRID project is that you may want to start at the intermediate product, right? So you may want to start at the pre-processed data. You may want to start from the raw data. You may want to actually change just a component of the input file. So you don't want to change the molecular model, for instance, that you're submitting, but you do want to change the parameters that are given to the application to run that. So if you divide them into, this is the instructions for the analysis and this is the actual data, then you can change one without changing the other. And again, this is useful in some cases and not useful in some cases. And the granularity is really going to be up to the researcher and what is useful, or the community and what's useful. In fact, one of the projects that we looked on early on was called the Perseus digital library. And the question they had is, with text analysis, do you want to put a PID on a chapter? Do you want to put it on a page? Do you want to put it on a letter, a word? What is the right granularity? And I think that now this is not what they came to, but I think the applications are going to define what granularity is useful, right? So the applications that use this input data either exist or they will exist. You're going to solve the granularity problem based on the workflow and the application that you have doing your analysis. At this point, we're early enough that we're just showing that if you can put PIDs, and again, they're inexpensive enough, you can issue about 1,600 per second without putting any reasonable load on a machine on the server that is running a handle service, and along with populating its metadata. And you do need a license from the DONA Foundation to get a prefix, but that's about $50 a year. So if you're looking at billions of PIDs for $50. It's inexpensive to put PIDs on there. So the usefulness isn't going to be defined by a technologist. The usefulness is going to be defined by the research community, and in fact, the applications developers, I think, in the end, because you're going to want to feed the application what the application is looking for.
I'm really questioning just the resolvable part, right? The putting global identifiers on really small things so that you can reference them. You know, I think is something we can't. Right? You don't want to do that with a DOI, but things that don't need a resolver service, just to have those PIDs that can be connected to a DOI level or to a higher level, I think has a place in this game too. So I'm curious that, you know, this is sort of, there's DOIs, there's what you're talking about, and then there's just persistent identifiers that aren't resolvable, that are even cheaper. And I'll be curious to see where the breaks between those three things really turn out in the long run.
Yeah, and I think that, I think that in the end, DOIs are going to be, you know, the final that describes the entire data process, the data set, and maybe even the workflow. But in that, you can have small things. And again, we're resolving is only resolving a very small kernel of metadata, right? So you're not looking at if it's resolvable, getting the only difference between the PIDs we're using in the RAPID project and the PIDs that are used as DOIs is that the metadata schema behind the scenes is much more structured and rigid and larger for a DOI than it is these PIDs. These run on a very minimal scheme. And yes, I think there's still a lot of open questions as to where the usefulness, or what level of usefulness this will be. Will it be that in the end we decide that really it's only useful to put PIDs on data when it's published and put somewhere like DataCite, or is it useful to use PIDs at this workflow level, which is what we're doing?
And Rob, I think at this point your boss is probably waiting, so we might say thank you.
And I do encourage anybody who has more in-depth questions to get a hold of me. I've put, and I think this is still up, I think I'm still sharing, links to the RAPID project itself, the testbed, the FAIR digital object group, and then if you're really interested and want to listen to me talk about this for an hour with a little bit more of the technical details instead of the shortened kind of high-level overview, I've put in a videotape presentation there.